Hi, my name is Pavan Kumar. I am from Dennis Scott. Now we are going to discuss .NET framework through ajiho.com. Ajiho.com is a training organization for .NET technologies. Now we are going to discuss .NET framework. .NET framework is a runtime environment or execution environment for 9 Microsoft defined languages for application development. 9 Microsoft defined languages for application development. Okay. Now this .NET framework will support not only 9 Microsoft languages but also 61 other languages developed by different organizations in the world. That's why .NET will be called as .NET framework. .NET framework will support 61 languages, and these 61 languages can be transformed into native code by .NET framework. .NET framework is a very powerful environment to transform the languages into native code. Native code means the language which can be understood by operating system. Once the operating system understand the native code, then only applications can be developed. Okay, now we are going to discuss what is a .NET framework and what are the integral parts of .NET framework. So now we are going to discuss the common language runtime, which is a predominant part of .NET framework. .NET framework consists of common language runtime. This common language runtime will have different specific parts with specific duties. Let us see this word. This common language runtime will have common language specification and common type specification. This common language specification will understand the syntaxes of any language. Syntaxes. There are 61 languages defined by different organizations in the world. These 61 languages will have 61 type of syntaxes. So if you give any language, that language syntax can be understood by common language specification. And each and every language will have a data type. This data type can be understood by common type specification. The common language specification will understand the syntax of the language, and the common type specification will understand the data types used in any language. So, like this way, these two things will convert this language. The first level conversion will be done into intermediate language. This intermediate language code again sent to just-in-time compiler. Just-in-time compiler will be called as JIT compiler. This JIT compiler will convert this intermediate code, this intermediate language code into native language. This native language code. This native language code will be working on operating system. So native language is a language which can be understood by the operating system. Then automatically the language can develop an application on operating system. So in a nutshell, I would like to tell you how the languages of Microsoft, let us just say an example. C# is a language defined by Microsoft. This C# language, how it will be transformed and how it will be converted into native code, let us discuss in a nutshell. Okay, so once this C# language is written, and this will be going to common language runtime. This common language runtime will have Microsoft compilers. These Microsoft compilers will compile the C# language with the help of common language specification and common type specification. It will convert that code, C# code, into intermediate language. Once again, I will tell you, C# language defined by Visual Studio, defined by Microsoft, will be coming to this common language runtime. Common language runtime will have predominantly a compiler. This Microsoft compiler will convert this C# language into intermediate code with the help of CLS and CTS. Once the intermediate code is developed, this will be sent to just-in-time compiler. Just-in-time compiler will convert this intermediate language code into native code. Native code is the predominantly understood by the operating system, and the operating system will develop the applications desired by the programmer. Now we are going to discuss the predominant and very, very important part of common language runtime. The common language runtime has rich with a memory management tool. This memory management option can be provided by garbage collector. This garbage collector is a memory management part of CLR. Whenever an application development is happening in CLR, that application will have objects. So these objects will attract variables defined by users. Whenever users are inputting these objects need to be captured by some memory. The memory will be provided by garbage collector, and the memory, whatever allocated by the garbage collector, again will be de-allocated by the garbage collector. And the process how it will be run, let us see in example. So CLR will have 4 parts: CLS, CTS, JIT. And we have discussed how CLS and CTS and JIT will convert the code of C# or code of VB or code of F#, which is defined by Microsoft, into native code. And now we are going to discuss the garbage collector. Garbage collector is a part of CLR which will be used for memory management. Memory management. Memory management means allocation of memory or deallocation of the memory. The memory allocation and memory deallocation will be done in such a fashion. Let us consider an example. Suppose the programmer is developing a ATM application. So in ATM application, the first instance will be asking to read the card of the ATM card. So whenever the card number is read by the application, that reading information, the card information has to be captured by some memory allocation. So garbage collector will allocate the memory for the card number, and it will store the card number in certain memory. Card number will be allocated by garbage collector, and this memory will be allocated by garbage collector to store the card number. Okay. And second, once the card number has been stored, it will go to database, and in database will check the card number. If the card number is available, then it will send the process of going to the next screens. So in the next screens, the ATM will ask PIN number. So the PIN number will be inserted by the user. Once the user inserts the PIN number has to hold by some memory. So the memory again allocated by the garbage collector to hold the PIN number. So in the third instance, the PIN number will, second instance, the PIN number will be going to the database and it will check the PIN number is correct. When the PIN number is correct, it throws the third screen. So in the third screen, there is the amount will be entered by the user. Let us say 15,000 rupees. So this 15,000 is again has to be stored by the memory. So the third time also the memory will be allocated. So this memory is first instance some memory, second instance for a PIN number some memory to enter to capture the amount of the user, that also has to have some memory. So there are three types of memories has been allocated by garbage collector. So let us see how this memory management will be incorporated in garbage collector. So there is generation 0, generation 1, generation 2. So generation 0 is a memory block which is going to allocate the memory for the first instance objects. So whenever the card number is allocated, the first instance objects will be created in generation 0. So once the generation 0 is holding this allocating this memory for the card number, then the second instance will go to generation 1. The second instance demands for PIN number. Once the PIN number is allocated, this second instance will be allocated by the G1, generation 1. At the same time, the previous memory also will be carried over to generation 1. So once this generation 1 is refreshed, so whenever the card number is not used, the card number is not used in the second instance. That means in the second level of application, the card number allocation memory is not required. So at that moment, the refreshment of generation 1 will nullify the deallocate the memory allocated for the card number. So generation 1 will carry over this PIN number to generation 2. So in the third instance, this application needs to hold 15,000 rupees in the memory. So this third memory allocation, the third memory allocation will be allocated by the G2, and after allocating memory, G2 will again refresh. Whenever G2 generation 2 is refreshing, automatically this PIN number which is not in use, again it will be nullified. That means it can be taken back. So like this way, the generation 0, generation 1 and generation 2, these are all the memory blocks maintained by garbage collector. This garbage collector will automatically allocate the memory and deallocate the memory. As and when it is required, it will allocate. As and when it is not required, it will deallocate the memory. So this is allocation and deallocation of memory will be conducted by garbage collector. That's why this will be called as background memory allocation process. Background memory management process. Thank you. Then we will see base class library and framework class library. .NET is rich with lots and lots of classes. These classes are depicted in the great base class libraries. The base class libraries can be distinguished as framework class libraries. The framework class libraries will have lots and lots of classes which will be time to time used by the users of .NET. So the users of .NET will feel very happy, very easy to use the base class libraries. The base class libraries will be predominantly distinguished into two types. One is assembly, the second one is namespace. Assembly means the user defined classes can be named as assemblies. The assemblies will be written by users while they are programming the application development. The namespaces are very predominant, which will be available in .NET framework. This .NET framework is having a very big storage place which can be named as base class libraries. These base class libraries will be consist of namespaces. Namespaces means for different activities, different classes will be formulated and it will be stored in the base class libraries. And coming to these assemblies, the assemblies again will be classified into dynamic link libraries. Dynamic link libraries will be developed by the users according to the specifications demanded in application development. While they are developing applications, users can develop different types of classes. These classes can be again and again reused by the programmers in their programs. So, these DLL files are not developed by using main class, main method. So, main method, once you use main method, whatever the classes, whatever the programs you will be developing will be converted into executable files. That's why the base class libraries, especially the assemblies, can be distinguished into two types. One is dynamic link libraries and second one is executable files. Executable files can be developed by the programmers along with all components, all pages, all user interface screens and everything related to a project, and it will be converted into executable file and which can be deployed at the client's place. Once the programmer converts the programs into executable file, this executable file cannot be opened, cannot be used for other programs by the programmers. Okay, so base class libraries are divided into two types, assemblies and namespaces. Namespaces will be predefined classes defined by the .NET framework, and the second one is assembly. Assembly will be defined by the users while they are programming. These assemblies can be divided into the dynamic link libraries and executable files. Thank you.